Hi students, hoping that you are doing well. We are studying 6th semester elective Ground Improvement Techniques. We are studying the 5th module of Ground Improvement Techniques, Compaction, which is a type of mechanical modification. In the previous sessions we have covered the topics: what is compaction, what is the advantages of compaction, what are the factors affecting compaction, and the soil moisture density relationship, etc. And in the last video we have studied about the field compaction techniques or the shallow compaction techniques. Now in this session our topic of discussion is deep compaction. What is deep compaction? Deep compaction techniques are required when inside soil extending to large depth does not meet performance requirements of performance criteria specified for the expected loading and environmental conditions. Usually, the deep compaction is provided for a depth of 10 to 30 meters for densifying the soil. Now, the methods of deep compaction. The different methods of deep compaction includes: first one, pre-compression or pre-loading; second one, explosion; third one, heavy damping; fourth one, vibration; fifth one, compaction grouting; sixth one, vibro compaction and vibro replacement. First one, pre-compression. A site is preloaded by means of a surcharge or by lowering the groundwater level, causing the ground to consolidate. Here we can see the surcharge, the preload, and here it is the slow draining subsoil. This technique is used for cohesive soils. So, the pre-compression techniques is used for cohesive soil. For densifying the cohesive soil, we are using the technique pre-compression, in which we are using a surcharge and preload for densifying the soil. The surcharge fills are 10 to 20 feet thick and generally produces a settlement up to 1 to 3 feet. The second technique is explosion. Explosives are detonated on the surface in an array of boreholes, causing loose soil structure to become denser. Here we can see the detonation point where the explosives are charged. The material location is represented here. The blue line indicates the air, green TNT, that is the detonation point, and the red indicates the soil. About 500 mm is the air, and about 20 mm it is fixed as the detonation point, and about 500 mm there is the soil. The final density may not be achieved immediately, as the dissipation of excess pore pressure generated may take some time. Next is heavy damping or dynamic compaction. A large mass is dropped onto the ground surface, causing compaction and long-term consolidation, which is termed as dynamic compaction. A large mass is suddenly dropped into the ground surface, which causes the densification of the soil, and that results in dynamic compaction. The dynamic compaction has been extensively used to compact loose soils to depths of up to 10 meters. To increase the bearing capacity and to decrease the post-construction settlement and mitigate the liquefaction risk in case of seismic events, we are using dynamic compaction. Here we can see the dynamic compaction. A large mass is dropping onto the ground surface, which results in the compaction or a long-term consolidation. Here we can see it. Here it is the loose soil. After the dynamic compaction, it becomes dense. Next is vibration. Densification is achieved by a vibrating probe here or by means of a pile. Sometimes it is aided by water jets or pressurized air and the addition of granular material, possibly with added cement agents surrounding the soil. Here we are penetrating the probe or pile. After that the compaction is made and later that the backfilling is done. Here we can see the compacted soil. So it is the operation of penetration, here is the operation of compaction, and here is the operation of backfilling, and finally the finished or compacted soil. Here we can see. So densification is only achieved by a vibrating probe or a particular type of pile which is aided by means of jets or pressurized air. Vibration is most suitable for free drainage soils. The impact loading, explosion and heavy tamping are suitable for less pervious silty sand. Next is vibro compaction and vibro replacement. Vibrators are generally attached to the top steel sections which are lowered into the ground. The dominant direction of vibration is vertical. Here in this figure we can see the vibrators which are penetrating into the ground. First one charging, next is the penetration, compaction, and here we can see the finishing process. The objective in vibro compaction is to achieve the densification of coarse grained soils with less than 10 to 15% of silt in it. Next is stone columns. It is a type of vibration or vibro compaction technique. Here the dynamic load forces piles to vibrate and penetrate into the ground that result in densification and vibrations of the soil surrounding the pile. Greater stiffness of stone columns compared to that of surrounding soil causes a large portion of the vertical load to be transferred to the columns. So stone columns is a suitable technique of ground improvement for foundation on soft clay is to install vertical stone columns in the ground. This comes under a type of vibro replacement. The stone column method is essentially for soil reinforcement where the soft cohesive soil is replaced by compacted stone in pre-bored vertical holes within the soil. The stone columns serve two basic functions. First one is providing reinforcement to the soil, and second one is acting as vertical drains to allow the subsoils to consolidate to occur quickly under any given loading. So stone column is a type of vibro replacement. It is one of the most important deep compaction technique. Compaction grouting, we have already studied it in the second module. The procedure for compaction grouting is already studied in second module. So here I am not discussing about that particular portion grouting. You have to recollect it from the second module. Refer the notes for second module, you will get the compaction grouting there. So now in this session we have studied about the various deep compaction techniques such as pre-compression or pre-loading, vibro replacement, a type of vibro compaction, that is vibro replacement, a type of vibro replacement. You have studied the stone columns. The previous year questions asked from this part include: first one, with neat sketches explain vibro compaction method. So in this question you have to answer, first of all you have to answer what is deep compaction, which are the techniques used for deep compaction, and explain the importance of vibro compaction method, not more than 5 sentences, and after that explain the procedure for it and appropriate sketches for it. Then you will get 7 marks. Explain the deep compaction method of explosion with neat sketch. It carries 6 marks. So first of all, you have to define what is deep compaction, what is the peculiarity of deep compaction by the method of explosion, and explain the procedure for that with a neat sketch. Next question, briefly explain dynamic compaction method using neat sketches. You have to explain the dynamic compaction method and its procedure with neat sketches. Next is list out the different types of compaction techniques for ground improvement. You can specify the compaction techniques as shallow compaction techniques and deep compaction techniques and list out the different types used for it. The question covers for 5 marks. So after listing out all the shallow compaction techniques and deep compaction techniques, you will get 5 marks. Next is the assignment question. Hoping that you have understood the portion deep compaction techniques, we have studied about the various deep compaction techniques. Go through the textbook and read it detailedly, and after that answer these particular questions. First question is that differentiate between static compaction and dynamic compaction. So mention any 5 differences between the static compaction techniques and dynamic compaction techniques. Second question, list out the advantages and disadvantages of stone column method. Stone column method is one of a vibrio replacement method for deep compaction technique. So list out what are its advantages and what are its disadvantages. List any 5 advantages and 5 disadvantages. What are the different shallow surface compaction methods? Explain. This is the third question. First of all, you have to define what is shallow surface compaction or field compaction. Then state the importance of field compaction. After that, list the different methods used for shallow surface compaction and briefly explain any 3 methods, and submit the assignment either by Laneways or mail me the answered questions. So stay safe. Okay, thank you. Study well.